roboticist, welcome back in this new video where we are going to learn how to make a collision checking with our 6-axis robot using MoveIt. So for the moment we will need to add just a cylinder and add to our scene. And so we are going to learn how to do that. We have learned in the last video how to do in using the RV's MoveIt plugin, but is very useful to know how to add an object with C++ code using MoveIt API. So before continue, make sure as always to subscribe to the channel to not miss the next topic, and why not, if you like this video, you can make a donation. I'm gonna provide the link in the description down below, and this will be very appreciated because you will help me to continue doing and motivate to keep this channel open to new topic in robotics, and in particular in software development in robotics in ROS. So if in the motion planning we have used the algorithm that is named inverse kinematic, which is a solving algorithm, for performing the collision checking, we are going to use this library, the flexible collision library. And this is an open source project that implements various collision detection and avoidance algorithms. So imagine that you're gonna have some object in your environment, or better the octomap. We're gonna see in a minute what an octomap is, and you need to track the position of the object and what is the relative position of that object related to the end effector of your robot. And why that? Because you can imagine that the motion planning will be solved in accordance to the objects that are present in the environment. So we need, for example, to avoid that pathway if the end effector will collide with the object. So we have talked about the object, and what these libraries can do is to implement a 3D occupancy grid that is called Octotree, or better, which is the octomap. You can see here some picture of what octomap is. So basically you are going to, let's say, to create your environment in some kind of squares, and that detect if there's an object that might be affected from collision or not. And as with the motion planning, you can imagine that the collision checking is very computational intensive. So what you will need to do is to set up, let's say, an allowed collision matrix. Why that? So you're not going to make any calculation collision probability of one object with respect of another. For example, well, we have seen something similar in the MoveIt setup assistance, where, for example, the link that are far away, for example, the base link and the link 4, there's no possibility to get hit between each other. So basically, if we want to summarize, if the value of a collision between two links is set to 1, there will not be any collision checks. There will not be any collision checks. So we may set these 4 links that are far from each other, as I said, and we can optimize the collision checking process by optimizing the metrics. So what you can do is to create a new script file in our Cobot test package that we have set up in a previous video, and we are going to create a file, and we can call it add collision object. So first of all, what you will need to do is to import the libraries that we need to use for using this tool. And as you can see, we have the move group interface, the planning scene interface that we have seen in the last video, and then something new here is the attention collision object and the collision object, which are some message that we will need to create an object and to put into our scene. So now what we need to do is to create our main function as always. And then, as always, what we need to do is to initialize a ROS node and give it a name. Here we go. This node is gonna call add the collision object. Then we need to create our node handle object. Then we create our spinner object, and then start the spin object. What we need to do now is to create an object that is going to be of type planning scene interface, which can access the planning scene of MoveIt, and from that we perform any action on the current scene. So we are gonna sleep the node for 5 seconds. That we allows the scene to be interfaced in our environment. Then we need to create a cylinder. And what is a cylinder? Well, it belongs into the MoveIt message. That we will use these libraries. And so we just needed to create it. MoveIt message, then it's gonna belong into the libraries collision object, and then we're gonna call it cylinder. Okay, and then we need to set up an ID, which can be that will be the name of our collision object, which is very important in order to identify of which type of object we are dealing with in our scene. So cylinder.id, and we can call it Cobot cylinder. So equal to Cobot cylinder. And then this cylinder is belonging to, let's say, a primitive shape. So imagine that you can add to your scene no matter object you want to different shape, but for the scope of this tutorial, let's keep things simple, and let's rely on the shape message solid primitive libraries. So this is a way to simplify how to use the properties of the primitive object. So we are gonna create a shape message. Then there will be a solid primitive, and then we can call it primitive. And this primitive will be of type cylinder. You can have, you see, a cone, a cube, let's say primitive shape. And then now we need to give a dimension. Now we need to set up a pose. So we will need an object of type geometry message pose. And then we are gonna set the orientation and position. So we are gonna define only the real part of the orientation. This is a Quaternions convention. So then you need a position in X that we can set, for example, at 0. I remember you that our robots has the base link in 0, 0, 0 position of our scene, and then we can set up the position in Y and Z. So after defining, let's say, the pose and the collision object, we will need to add the defined primitive object, the cylinder, and the pose to the cylinder collision object that we have created before. So after that, so we need to push back the primitive, and then push back the primitive pose, and we need to add into the scene, and for this we need to update the cylinder operation. Then in the next step we need to create a vector that we can call a collision underscore object, and this is of type MoveIt messages collision object. And then we are gonna insert the collision object into this vector, and this vector will store, let's say, all the objects that we can create in our scene. Finally, we need to add into the scene our collision object vector, and to do that you just need to use the function add collision object, and then insert the inside the brackets the vector that we have just created. Then we can sleep for 2 seconds to allow all the object to appear, let's say, into the scene. And then basically this script is finished. We can shut down after that and then return 0, so we can close the main section. Okay, everything should be done, and And now with this script you should be able to spawn a cylinder of size 06, 02, 02, and in the position 0, -1 and minus 0.4. So basically, as a recap, we have included our libraries, then we have created a planning scene interface object. Then we have created our cylinder, which is a primitive object contained in the, let's say, solid primitive shape message. And then we have created a vector where we put all the objects that we want to appear into the scene, and then we use the function add collision object to basically add the object into the scene. So I remember you that before to test it you will need to create an executable file from the C++ script that you have just created. So let's do that. So now you can build your package with the catwing make. Okay, there's an error, and yes, it seems that I have forgotten to create the pose object. Otherwise, of course, the orientation and position cannot be tracked. So we add the pose, and now it should be okay. Okay, the package has been created. So we can, as always in this series, we are gonna launch the demo launch file belonging to the Cobot MoveIt configuration package provided by the MoveIt setup wizard. Okay, and then what we can do is to spawn the collision object that we have created. So we could run the node, so ROS run, then the package and the executable file that we have just created. Okay, it seems that okay, I put the Z position wrong. Probably I forgot to make I have put a minus. Let's check into the code. Yes, in fact the pose position.z is minus 0.4, so it should be plus 0.4, of course, otherwise it's below the floor, the imaginary floor, and we will not be able to spawn correctly in gazebo. So let's build the package again. And now the object has spawned in the position that we wanted. So it's appearing green, and then if you go to the plugin motion planning, you can see that the Cobot cylinder it's cylinder ID that we have set up in the code, and then you can use the pose, scale, errors in order to place the cylinder in the position that you want. So I just wanted to let you see these things. So if now the object is approaching, or better is touching the robot, then the link of the robot that has been touched should be turn the color in red. Let's check it, and if we make the end effector of the robot get closer to the object, then here we go. You can see the gripper and the gripper connectors that is turning in red. Of course, you feel free to change the color, but this is the main activities that I wanted to show you. So basically, that's all for today. I hope that you enjoy this video. If you enjoy, please subscribe to the channel in order to do not miss the next topic. And if you like this kind of video, consider to make a donation for this channel and to help me in creating more content like this. So in the next video there will be an important one. So in the next video what we're gonna do is to understand how to attach a collision object to a robot link. So this cylinder that we have created, we are gonna see how can be grasped correctly and how can be attached to the link in order to be correctly picked up, which is the base for pick and place application. Again, thanks for your attention and keep learning robotics with Ross.